Welcome to Become an Expert, brought to you by Kendrion. In this series of product-related videos, we will provide a comprehensive overview of the functionality and application of electromagnetic brakes. So join us as we explore the fascinating world of electromagnetic brakes.
In this training video, we will be looking at what does an electromagnetic brake look like? What is the function of an electromagnetic brake? Where are electromagnetic brakes typically mounted? And what are the typical integration scenarios of an electromagnetic brake? So let's start. As an introduction to electromagnetic brakes, I have a selection of various electromagnetic brakes here. As you can see here on this side here, we have three representatives of the permanent magnet brakes, whereby here this is one of our smallest permanent magnet brakes. Here on this side, we have 6 different spring-applied brakes. Each have its own function, different set of features, but we shall look at them as we go through the various videos. On the bottom here, we have 2 of the servo slimline brakes. The name slimline because of its height. As you can see, the brake is quite short for its overall height. Here we have the servo line brakes, and on the back we have 2 representatives of the BFK family of brakes. As I mentioned, we will go through each of these brakes in turn as we go through the set of videos and to build up the knowledge as we go along. Let's have a look at the function of an electromagnetic brake. There are basically 3 different functions that an electromagnetic brake can fulfill. The first one is a holding brake. The second one is a holding brake with emergency stopping capabilities. And the third one is a working brake. So let's take the time and we will go through each one of these in detail, and we will have a look at the function and the differences. But before we continue, let's have a quick look at a typical application of how a brake is used, that we can understand the differences of the 3 different applications. Here I have built an application. Here we have a disc sitting on a shaft. It is loading and unloading a load of about 20 kilos. As it rotates in one direction, the load moves up. As it rotates in the other direction, the load moves down. Here I have a schematic representation of a brake. This part of the brake here and here is representative of the hub of the brake, which is connected to the shaft. These 2 parts here are representative of the housing of the stator, which is then mounted onto a holding plate that holds the brake in place as the application rotates. And at the end, we have a very simple motor that is connected to the shaft that rotates, as I mentioned, our application forwards and backwards to lift our load up and down. So let's continue. A holding brake. Here we have got 2 parts. We have the upper part of the screen, which describes the application itself, and here we have a second half of the screen here below, describes the function of the brake. The brake has got 2 statuses. It's either closed or it's opened. Here, let's have a look at our example application. The yellow line, as you can see here, is the speed of the application. So our example application goes from no movement, i.e. standstill, up to a certain speed. Then it stays at this speed for a while, reduces its speed, and then here, as you can see, ramps down either to a no movement scenario. Here on the left hand side, or superimposed on the green, we have the power consumption of the motor, which just says here no power, low power, medium power and high power. Okay, so let's continue. So here the shaft, or the application itself, it has no movement. Why does it have no movement? Because the brake is closed, and when the brake is closed, the application cannot rotate. So there's a point in time here, let's say this is the point in time here, where the controller of the application says, okay, I would like to move the application. So the brake is then opened and the shaft is then free to rotate. So here we can see the application is doing its application by moving the load up and down at various speeds, And then there's a point in time in the future where the application said, okay, I would like to stop the application and hold it in position. And at this particular time here, the application would then ramp down the speed of the application to 0. And here you can see the brake is then disengaged, i.e. switched to 0 volts. And then the application is held in place. So here, this is, if you wish, the first example of how a brake holds the application. Therefore, it's called a holding brake. Next scenario, same scenario of application. In this case here, we have an emergency stopping function. As you can see, the application is still doing the same work. It is ramping up to a certain speed. It is then moving the load up and down. And then eventually, at a point in time, somebody presses the emergency stop button. What happens? The system is then powerless. The application has no more voltage, no more power placed to the system, and the brake will immediately engage. And it'll take a little amount of time, a finite amount of time for the application to come to standstill. And during this period here, the brake is using its friction surfaces to slow down the application and eventually bring it to a standstill here. Okay, so same application, but in this case here, the difference to the holding is that, as we saw in the previous application, the controller of the system was responsible for the slowing down of the application to a 0 movement, and then the brake was engaged. In this case here, the brake slows the application down and stops the application from moving. The last scenario is the working brake scenario. The working brake scenario is slightly different to that of the other two cases that we were looking at. In this particular case, we have a motor who is running on a fixed speed. As you can see here, it is typically on an asynchronous motor or on a geared motor, whereby speed control is not that important. Then we have here an application that is running at a constant speed, and then the control system or the power off system of the motor wishes to stop the application. In this case here, there is no ramp down. So in other words, the motor is just simply powered off. In this case here, the brake is engaged. And over this period of time here, point 3, the brake is used to slow the application down from its application speed to 0. Here, what is this here? Typically speaking here, when an asynchronous motor is powered off, the application may speed up slightly because of its load. And then here the brake comes in and slows down the application to 0. As we saw, there are 3 typical applications. First one is a holding brake. In this case, the application comes to a controlled stop through the control system and the brake is engaged. Hence, it is then as a holding brake. Then we have the second application, which is a holding brake with emergency stopping capabilities. In this case, we have an emergency situation. The application is powered off and the application is stopped in a minimum time through the brake. The last scenario is a working brake, whereby the motor is powered off and the brake is used to stop the application in a minimum time.
Let's have a look at one of the typical integration scenarios of electromagnetic brakes. In this case, the electromagnetic brake is mounted externally on the motor. In this particular scenario, you can see a typical motor. Here we have the shaft of the application, and here on the rear you can see the electromagnetic brake. How is it mounted? Here I have another brake. As you can see here, the brake is just simply mounted onto the shaft of the application, and here through the mounting screws, as you can see here, the brake is mounted onto the rear flange of the motor. And this is a typical scenario of externally mounted brakes. Here we have another integration scenario of an electromagnetic brake. In this case, the electromagnetic brake itself is mounted inside the housing of a motor, and we speak about internally mounted brakes. Here
we have a servo motor in this particular instance. Here we can see the shaft of the application, and the brake itself is mounted onto the A side of the motor. If we were to look how it's actually mounted, here I have another electromagnetic brake. In this case here, we can see that the brake is mounted here through the mounting screws here onto this part of the motor itself here. So the stator is mounted, and here we have the rotor. It rotates with the shaft. Again, the key word here is internally mounted brake. Before we continue, I think it's important that we have a look at the various integration possibilities of the electromagnetic brake technologies. In this case here, we will be looking at the spring-applied brake technology, and in this particular application it is used in the industrial trucks. And along here, you can see here on the motors, along the power transmission of the industrial truck itself, there are two motors which are engaged with the front wheels, and on each motor you can see the externally mounted electromagnetic brake. Another application of the spring-applied technologies would be in the wind power turbines. In this case here, there are two typical applications for an electromagnetic brake. One is called the pitch, which is actually holding the large wind turbine blades in place as the wind changes direction in order to achieve the optimum surface and to achieve the optimum energy generation. The second application is the so-called yaw or azimuth application that turns the turbine depending on the wind application. In this case here, the spring-applied brake can be used, but also in wind power turbines, the permanent magnet brake technology is equally usable. So here we have another application of electromagnetic brakes. As you can see, this is a totally different application than what we were just looking at. This is a surgical room, and here you can see many different devices, but here on the left-hand side you can see the so-called C-arm. The C-arm is a device that needs to be held in position, and typically here at this position you would find an electromagnetic brake. Here is another application of a permanent magnet brake. Again, this is an application of an industrial robot. In this case here, permanent magnet brakes are used in this particular instance, and as you can see here, on each of the axes of the industrial robot there is permanent magnet brakes that hold the application in place. Again, as we talked about, if there was a power failure, the brake would engage and the robot would not collapse, hence holding its load and its application in place should there be an emergency stopping function. Thank you for watching and listening to this training video. There are other videos that provide training material for the concepts of electromagnetic brakes and Kendrion products. So take the time and enhance your knowledge.